Hello, I'm Graham Lewis, and in this video we're going to look at fractions, finding equivalent fractions, using them to simplify fractions in their lowest terms, and also using equivalent fractions to help order a list of numbers. Let's start with our fraction. For example, let's start with 2/5. Now the 2, as you know, is called the numerator, and the 5 on the bottom is called the denominator. Just some posh words for the top number is numerator and the bottom number is the denominator. Now if we look at this fraction 2/5, what we can actually do is a clever trick and get lots of fractions which are identical to 2/5 by multiplying by 1. So if I take 2/5 and multiply it by 1, but I'm going to be cunning and call my 1 3 divided by 3, for example, because 3 divided by 3 is 1. So you can see that I'm multiplying the fraction by 1 because 3 divided by 3 is equal to 1. So it's still going to be the same value as 2/5. And so the rules for multiplying fractions are multiply the top numbers together. 2 times 3 is a 6 and 5 times 3 is a 15. So what we can say is that 6/15 and 2/5 are exactly the same number. If we were to draw them on a number line, here's 0 and here's 1, and 2/5, if I split this up into fifths, 1, 2, 3, 4, 5, 2/5 is here, and it's exactly the same number as 6/15. They are equivalent. It's the same number, it's the same value on the number line. And the trick is multiplying by 1. So you can see that as long as you multiply the top number by 3 and the bottom number by 3, you will get an equivalent fraction. But of course you can write your 1 in many different ways. You may choose to multiply by 6/6. So for example, if I wanted another equivalent fraction to 2/5, I can multiply by 6/6, and 2 times 6 is 12 and 5 times 6 is 30. So 12/30 is equivalent to, identical to, 2/5. And that's all there are. So there are an infinite number of equivalent fractions to 2/5. A really easy one is, of course, multiply by 10 divided by 10. Again, 10 divided by 10 is 1, so I'm not changing the value of the fraction. 2 times 10 is 20, and 5 times 10 is 50. So 20/50 is the identical number to 2/5. They're the same value. Okay, so now we're going to look at how we can use this to help simplify fractions. And basically, it's going backwards. So if I was to give you 20/50, for example, what I think of is, can you think of a number that goes into 20 and 50? Yes, I can think of 10. So what you can do is go backwards. Instead of timesing by 10, we divide by 10. So 20 divided by 10 is a 2, and 50 divided by 10 is a 5. And now, are there any numbers that go into 2 and 5? The answer is yes. Only one number, and that number of course is 1. So that's how you know you've got it in its simplest terms, when the only number that goes into your final top number and bottom number, the numerator and denominator, is in fact 1. So you've got it in its simplest terms when 1 is the only number that goes into the numerator and the denominator, is the only number that can be divided by. That's what I'll write. Okay, so let's do another example, and I want you to pause the video and try this one on your own. So I want you to reduce 12/18 by thinking of a number that goes into 12 and 18. Think of the highest number you can. That will save you time. And then simplify that in its lowest terms. Pause the video now, and then I'll go through it. Okay, so let's go through this. Well, there's different ways you could do this. The quickest way is, what's the biggest number that goes into 12 and 18 is in fact 6. So I'll divide the top by 6. 12 divided by 6 is 2, and I'll divide the bottom by 6. And 18 divided by 6 is 3. Are there any numbers that go into 2 and 3? No, only 1, so we're finished. That's in its lowest terms. So I'm hoping you got the answer 2/3. We know it's correct because if we take 2/3 and multiply it by 6/6, we get the 12/18. We're just going backwards. Okay, now there's another way of doing 12/18. What you could do is you could have picked the number 2. So if we divide top and bottom by 2, we get 6/9. Are there any numbers that go into 6 and 9 other than 1? Yes, 3. So we can go again. 6 divided by 3 is 2, and 9 divided by 3 is also 3. So we get the same answer. We just needed one extra step. And that's fine. If sometimes you want to do more than one step because it's easier, you can do that. So that's how we simplify fractions into their lowest terms. Now let's have a look at how we can order numbers by thinking of their equivalent fractions. Okay, let's have a look at this. I want to order these from the smallest to the largest. Always remember to read the question carefully. Sometimes they may ask you to go from the largest to the smallest. So I want to find the smallest number here. Now, what I'm going to do is just start comparing the first 2 numbers and see if I can get those in order. So I've got a 5 and an 8. What do 5 and 8 both go into? Well, in actual fact, I can do this 2 ways. Now, obviously, if I've got 3/5 and I've got 3/8, so if you imagine a pizza, I don't know why I chose pizza, I just like pizza. And if you imagine that pizza split into fifths, like that, equal fifths, and I've got 3/5, and then I imagine the pizza split into 8s. So I've got 8 slices, all equal, and I've got 3 of them. Clearly 3/5 is bigger than 3/8. So I don't actually need equivalent fractions for that. I know that 3/8 is going to be smaller than 3/5. And I could put a smaller than sign there. 3/8 is smaller than 3/5. Let me show you how to do it using equivalent fractions though, because it is helpful. Think of the number that goes into 8 and 5. And a number that 8 and 5 both go into is 40. So if I think of the number 40, I can write them both out of 40. What do you multiply 8 by to get 40? The answer is 5. So I need to multiply the top by 5 as well. So 3/8 is equivalent to 15/40. What do I multiply 5 by to get 40? I multiply by 8. So I have to multiply the top by 8 as well, and I get 24/40. So 3/8 is identical to 15/40, and 3/5 is identical to 24/40 using equivalent fractions. Now, it's really obvious that 15/40 is a lot smaller than 24/40. So that's how to do it with equivalent fractions. Let's continue now. We've got this 6/7 and 4/9. Now, using again logic, I'm thinking that 6/7 is going to be a lot bigger than 4/9, just thinking of that pizza. So let's just show that. So what number does 7 and 9 both go into? And well, 7 times 9 is 63. So why don't we write it as 60/3? What do I have to multiply 7 by to get 63? 9. So I have to multiply the 6 by 9, and I get that 6/7 is equivalent to 54/63. Now let's do the same for 4/9. What do I multiply 9 by to get 63? You guessed it, 7. So I need to multiply the 4 by a 7, which is 28. And we can see, as we suspected, that 4/9 is smaller than 6/7. So now I've got that I think that 3/8 is the smallest. I know that probably 6/7 is the biggest. And now I've got these 2 numbers in the middle. 3/5 and 4/9. And I'm not sure maybe which order they go in. So now I know 3/8 is the smallest, 6/7 the biggest, but 3/5 and 4/9. So let's go again. 5 and 9, 45. What do you multiply 5 by to get 45? 9. So multiply the 3 by 9 and I get 27. So 3/5 is equivalent to 27/45 because I've multiplied top and bottom by 9. Now let's do the other one. What do I multiply 9 by to get 45? 5. So I need to multiply 4 by 5 as well and get in 20. And we can see that 20/45 is smaller than 27/45. So in actual fact, I need to swap these 2 around in my order chart. So finally, my final answer is 3/8, 4/9, 3/5, and 6/7. And that's how we can use equivalent fractions to actually work out order of size. Thank you very much. That's fractions 1. Don't forget to practice these. You only get better when you practice. Good luck.